and then you could do something like duplicate here. Right, when you do a new thing, new item, you could duplicate it from the existing item. Copy from item, billing, service, something. We used to copy from this template and create for every this thing separate thing. So that's how we used to traditionally create the services, right? All of these, whatever we have, probably right now we have around 100, 150 items. So all of these were manually created like this. Okay, and every time somebody wanted to onboard a new service or develop, then he had to come to the DevOps guy and then he would say create it, and then he would first copy from an existing item, and then we would also need to configure all of this one by one. Things like which Git repo we should check out from, no, and what are the other variables that needs to be used. All of this, like branch parameters, right? Alternate repo push, setting the SEM credentials, repository URLs, the Jenkins file path. All of this needs to be manually set. That's what it was doing like before. Now this was cumbersome, and it was it always took time, and it was always you had to depend on somebody else to get a pipeline up and running, and there used to be a lot of mistakes happening, and instead of all the pipelines having the same structure, one pipeline would have a different structure. Somebody would forget to copy the branch parameter, right? And then if you needed to add a branch parameter kind of drop down, or and modify some of the text of it, or modify any pipeline basically, so you had to go to each of those pipeline and then modify them. So another 150 files you need to go and or clicking 150 jobs and then modify, and you have to make those changes there. So the entire thing was hectic, and then if you move the cluster again, you need to get your same volume around to the other cluster as well. Otherwise, it's difficult. And imagine you're doing this to give it to a third-party partner, right? In case you're giving the Jenkins as a service kind of thing to a third-party partner, you would have to tell him install Jenkins and then create the job pipeline for all these services manually, right? So somebody there had to open up and do that one by one, one by all by himself. So that is not really practical and would have taken. We couldn't have open sourced or given the Jenkins CICD to the partners like we do right now, right? So the idea now, what we've done is we run a Jenkins build called Job Builder, which would then go and search various configured repositories for a particular build config YAML, right? Now, the config YAML is this. What this config YAML suggests is, how do you basically create that jobs, right? So these jobs that you see here are basically they can all be mimicked, like they all have a similar pattern. You can extract all the common parts and make it a config driven building system itself. So that's what's being done. So whenever somebody wants to onboard a service, he needs a few configurable options. One is to put the structure here. Now this, which said this is almost like a Jenkins folder structure. It is a Jenkins folder structure, which says um, create this job in the builds course, in the parent directory will be builds, subdirectory is core services, then the subdirectory is ego access control, the job itself, right? This is how it needs to be structured, right? This is what everybody wants, because some people want their builds in utility, some can be dependent on could be related to a particular service, maybe a business service item, or an infra ops item. So those, if they're structured according to that folder, it's always useful for them. So that kind of requirement was always there. So that is the first part of it, which says what is the name of the folder you want in Jenkins. You need to specify that, right? So that's what it says here as well in the readme itself. Now next part of it is the working directory. It's like you want to execute this job, right? And where exactly, because we are using a single repo, So we are using a mono repo style, wherein one repo is not always going to have just one application at its root. Rather, you will have n number of applications in a single repo, which means you cannot just check out this repository and then say, let's say, Maven clean run itself, right? Clean build, because that would run it at the project root. But we don't need that. We what we need is when somebody runs a build of this, service, we need this maven build to happen in a particular directory, which is ego access control. This is from the root of the git repository, right? Which means what you're saying is, check out the repository, cd into ego access control, then execute the docker file, which is, execute any command from here, because the context and the work directory that will be taken, we will pass the working directory as this. So when you run the docker file, the working directory will be this. So then you can do copy dot slash of src, which means you will get the src which is inside of ego access control. Okay, any questions on the working directory part or the, build name part?
No. No.
Okay. Okay, so after these two, the next is the image name itself, right? Now, what is the image name that needs to be taken in the Docker image? The final Docker image that you produce, what is the image name that it should be? Now, this is usually always going to be the same as the convention as the service name itself, right? And what happens here in this case? So there is another script. Again, we'll go through the scripts eventually. But before going there, what happens in the image name is we collect all the image names for all the builds whenever we run the job builder. What we then do is we check in our configured repository saying, does the image repository exist for all these, images that we're planning to build? And if they don't exist, we'll pre-create them when we run the job builder, right? And it's ready to do a Docker push after that. Okay, so this phase happens here when we run the job builder. Okay, so this image name is used for two purposes. One is, what is the final image name that needs to be pushed, and the other is to pre-create that, Docker repositories if those don't exist already, because a lot of Docker pushes will fail if the Docker repository doesn't exist on most of the accounts. Some of the accounts that can still be enabled, wherein if there is no repository, then it can just push it the first time the repository automatically gets created if it does not exist. In those cases, you would not need it. But in cases where you need to have the before you do a Docker push, the repository must exist. In those situations, this will come in handy. Okay, and then the final thing is the Docker file itself. Now, if you don't specify the Docker file, right, it will assume that the working directory has the Docker file. So the working directory is specified here saying eager access control, right? Which means if you don't specify the Docker files, specifically, it'll assume that there is a Docker file here, and it'll try to get that in the root of the directory. Okay. Now, again, this is all documented here, but yeah. Now, in this case, there are two arrays in the build itself, right? What this means is you need two builds to happen simultaneously within the same. So the image tag and that portion of it will still remain the same, right? This comes in handy mostly for the DB migration containers. So what we do is we again give the same working directory which says from the root, right? From the root, go to cd ego common masters, then cd into src, cd into main, cd into resources, cd into db, right? And as you see, there is no Docker file here specified, which means that the Docker file should exist in this location already. Let's check that. So it was source, main, db, okay, resources, db, right? Resource, main, resources, db. Then there is no Docker file here. So what happens here? It cd into this and run the Docker build, which and because it'll just pick this Docker file. Okay, so this is a config driven build job building, right? I mean, the parent job itself gets built using this config. So the main concept, key concepts are this. where the job exists on the Jenkins UI, right, or the Jenkins machine itself, is governed by what is written here, the directory structure you have written here, the path, right? It's governed by that. The work directory is where exactly is my working directory, where are my project files for this service that you're saying. Okay. Image name is what's the final image name that will be pushed to Docker Hub. Docker file, if it does not, if you have a common Docker file somewhere, or you have it outside or in a subdirectory inside of the working directory, then you specify it. If it is in the root of the working directory, then it will automatically pick the Docker file from there. Okay, so this is the main part of it, how the config is working. Any questions here?
No.
Fine. Okay. So now let's see the code which actually uh, does this whole thing. So the directory structure is fairly simple. So there are two folders. One is so this folder here. Now what this folder has is very, these are just models, right? Which means they just have like a container structure. Like what is the structure of the objects that are used in the application itself, right? And this is a little bit of code, generic code, which is not related to reusable code, let's say, for all the different uh, pipelines that we've written. If you see here, there are three files. These are the actual working project code, you might call it. So there's build pipeline.groovy, deploy.groovy, job builder.groovy. Now, let's say job builder and build pipeline, right? Both of them will somewhere use the config file here, right? Now, this config file, when you use it, this config parser, which is there in the source or gig of Jenkins, is commonly shared between both of the files. So that's why it's abstracted and put here. Now, in the models also, if you see build config.groovy, this is nothing but the actual thing itself. So if you see image name, Docker file, work directory, right? It is whatever is there in the config file itself. We just saw that build config.yaml, right? It is the same thing. This one. Okay, it is just serialized into this class. That's it. Now, whenever you run any of these, this will make use of those supporting code here. Okay. Now let's go into the job builder for now. That's for starters. Okay, so job builder. So what does job builder do? So job builder by default has a okay. So job builder says we are configuring these number of repos into the job builder. Okay, there are quite a few of them. Okay, so what we do here, this is the params.urls, right? Git URLs. That is what will come from here. Okay, once that comes in, what we do is we clone each of these repos one after the other. Okay, once we clone it, we go to this directory here. Clone that git repo dot/build hyphen config dot yaml, which is uh, the config YAML here in core services. Now, if you do municipal services, you get the same thing. Now, imagine here, if you do municipal service, right? It also has a build config. So every repository that's configured is expected to have a folder such as this called build/build config.yaml. Okay, so that is what it's going to find the build config.yaml. So here is the for loop which says check out these Git repositories one after the other. Get the build config file. Okay, you read that YAML. Config parser is what we showed here. That's this config, parser itself, which is getting used here, right? It will parse that config, and we will get the list of jobs that we need to be, created. So the first step to do it is it will create the folders. Okay. So when you've given the build config.yaml, These are the folders that you want: build slash municipal services. So now if all of them exist, it's fine. But for the first time when you run it, the build slash municipal services might not exist, the parent directories. So what it will do is just create all the parent directories first. Okay. So that is the code which is there for folders to be created or updated. That's it. Okay. So once you are out of this part of it, okay, this for loop. So the next what you would do is there's another for loop, and in this for loop you go through each of these elements that you've listed here. First element, second element, right? Third element. Okay. We go through that, and what we do is with that pipeline, the job DSL, right? We use Jenkins job DSL plugin. So here you have all kinds of very detailed documentation, and this is almost like the standard which everybody across the Jenkins world use, right? Pipeline job, or I mean the job DSL plugin itself. So here you can get the detailed description of what exactly each one does, what is the parameter, right? What is the git parameter? What are the allowed options for you? How do you specify a branch name default? So the entire full detailed description will be available here. We have just same copied, used this, try to find out what is suitable to reconstruct our this thing, and we have done that. So here if you see, it's the same thing: parameters, git parameter definition, right? Another boolean parameter, and then the definition CPS SEM means which repository needs to be cloned. Okay, so this is where we go to each repository. Okay, parse the build config file. Okay, and then we end up with the job DSL. This is a string, this entire thing, right? This entire thing we will get this for all the job, this job DSL, okay, as a string, and then we will try and append it and make it a big string. What we are doing is basically a huge job DSL string we create, a script, job DSL script that will form or create all the jobs. Okay. Once you have that, what we will do is we'll call the job DSL and pass it the job DSL script string. Whatever we gave the script, right, to got created, that script is passed, and the job DSL plugin, according to that script, will create all the jobs, whatever you've seen across all repositories. Okay, and that is it. And after that, like I earlier told, right, you have another create repo script which will create the images, Docker image repositories if they do not exist. Okay, now the code for that will be in the Docker file itself. There's builder utils. Here you can find it. So what this one does is for a given set of repositories, Docker repositories, if it does not exist, it will create those repositories. Okay, but usually a lot of repositories allow to auto create on first push if the repository does not exist. In that case, you don't need it. You can remove this step itself. Okay, as simple as that. Now, apart from that, the building jobs is pretty straightforward here. What we do is we go to each repositories, get the build config file, parse the build config file. Based on the build config file, we'll create this job DSL script. Okay, for each job. Once we have the job DSL script for all the jobs, we will give that job DSL script to the job DSL plugin. It will execute that script on Jenkins, which will give the job pipelines itself. With that job pipelines, you can, the process is complete, the job builder process. Okay. Any questions here?
Anything for you tell no the it will create a parent folder after subfolder, right? It's
Correct.
allow only to create a three folder. Yeah, we can specify many folders also.
You can specify any number of them.
It will create
It will,
automatically.
it will create it. I think we also have an example somewhere here where it's not a little bit longer. Don't know where it is. Right, you can see here. just build slash core service slash telemetry slash ego telemetry Kafka stream. Yeah, there's an extra level also, which also gets created.
And this flyway migration thing is it will Docker file just copy the SQL script, and at a time where it run actually exactly means where it get deployed to database.
That will be done not in CI stage. That will be done in CD stage. Okay, here we just package those scripts. That's all. In the
Hmm.
CI step, we don't run those scripts. All we do is package them and give. That is, in fact, see the flyway. There is no relation of flyway concept which comes in the CI stage. For the CI stage, this your job builder and the build pipeline, it can be anything else also. It can be a a DB migration script or some other sidecar container of whatever thing. We have not written any specific code, for how to do flyway DB container. It is all generic stuff. But what we use it this array for is usually for the flyway thing. That's all. Now, where is the code to actually do that is entirely part of the Docker file that you write. Okay, how you copy, what is copied, everything is part of the Docker file of the flyway DB migration thing. Okay.
Okay.
So the execution, again, we can see that, but that is always part of the init container. If that image exists in the manifest, right, the deployment manifest, you have like eager user, whichever has the database dependency, they have also defined that they need a flyway DB migration container, right? In that case, what we do is we get that DB migration container, run that at the development environment. If you are deploying, it will run there. If you're running in production, it will run there.
Okay.
Okay, so next is build pipeline.groovy. Okay, so what build pipeline.groovy will do is now you have this pipeline is ready now. Okay, what happens when you click build, right? That is governed by the build pipeline.groovy. That's all, nothing else here. Okay, uh, so actually this is like pretty straightforward. There's nothing much like in build pipeline. There's actually some sorry job builder. There's some logic and we've written some stuff, but here it's like pretty straightforward. One part of this is we get the commit hash. We make the image name, right? The image name is Docker image repository name colon the tag itself after colon, right? What we do is we put one or two or whatever the number is hyphen commit hash hyphen branch name, whatever you write, right? So that part of it done is here. So we will run something like slash trim get application version dot h folder commit all of that. When we write that, we actually get that commit hash that you see. Like if you see in any of this, right, you have the commit hash. Okay, version v1.1, this one. This is generated. That part of it is happening here. Now again, the code again is not kept here. The code for that is also part of the image itself, builder image itself. Now the advantage, why is this not part of Jenkins, right, or the script here? The reason is whenever you're trying to, let's say, migrate the CI from Jenkins to something else, or if you even want to do the testing on your local, testing Jenkins Groovy scripts are very difficult. You cannot test it on your local or something. You need to deploy and test. But what happens is when you abstract all this application or business logic, right, into separate Docker containers or separate shells outside of this pipeline, you can test them very easily. So if somebody wants to test whether my whatever get application dot script, whatever logic you have, or get folder commit, right, you will do this command. Now does this work or not? You don't need to deploy commit your code, run a deployment, then see if it is working or not. All you can do is you can check all of this locally. So that's why it's always a good practice to keep whatever code that you're writing, right, any business logic outside of this pipeline. This pipeline should just have as to okay, start this Docker image, run this script, start this Docker image, run this script. That's how it should be. Okay, and whatever hooks and things you might need to make Jenkins run, like job DSL. That is a Jenkins specific requirement. Like you need to run that, so that can be part of the pipeline itself. Anything else which can be used, reused, or easier to test, can be made easier to test, then they all needs to be abstracted to a separate Docker file where you can test very independent. Okay, so that is where the git commit will come from. So whatever you see in this build, this thing, right? So that is this after the colon. So that part of it is coming from this. This will call these scripts here, and it will give you the value. Now the actual build itself. Now this is all, most of these things are just some kind of uh, tests, like okay, in that config file you have given that the working directory is this, you've told that the Docker file exists here, but do those actually exist, right? So if the Docker file only does not exist, I cannot do a build. If the working directory itself does not exist, I cannot do a build. So just throw an error. Okay, nothing much there, pretty straightforward stuff. Then the actual push itself, now we have a thing where we pushed an alternate repo, right? This is a, let's say, pseudo code we have written. It's not, it can of course be refactored to a better thing, maybe to a better way, but as of now what this was doing is, if you want to push it to GCR instead of the default repository, which is our Docker repository, if you want to deploy it to GCR or something, when somebody checks the flag called push it to that GCR repo, it will push it to the GCR repo as well. So this entire thing is just a copy. Okay, it is the same. Okay, the only difference would be the repository name itself. Instead of sending it to AWS, sorry, Docker Hub repository, this will send it to the GCR repository. The destination is changing. That's all. Here the destination normal the image will push. Okay. Now these things, what are they? These flags that we have given, various flags. They are all flags that we have seen in the Kaneko class. I mean, Kaneko session. We just went through all of this, right? Some build argument that you pass, right? Nexus username, Nexus password, CIDB username, CIDB password. If some builds require that, they will get this as the build argument. The Docker file will be able to get this. Okay. So the build pipeline is, like I said, it's fairly simple. There's not much logic per se here. All you have is get some of these secrets from the environment, and we inject it. We pass those variables into the Docker files, and the Docker files will use those variables, the secrets itself, and do a Docker build, regular Docker build, but using Kaneko to that Docker build. That's it. Okay. This file is responsible for this, the actual build itself. Okay. Any questions here?
No.
Okay, fine. So moving on. Okay, so deployer, there is no deploy again. What we've done here, deployer.groovy, why is it so small and simple? Is we don't want to tie our deployments to Jenkins, right? Because previously we had done the same. What happens is if somebody does not have Jenkins, then they cannot really deploy, right? In the Python scripts way and stuff, we have all that looping code and comma separated. Those the entire loop running and stuff is written in Jenkins. So what we've again done is we've abstracted all of that into a Docker image. Okay, and then what this will do is just call that script, or that program. That's all this deploy.ruby does. Okay, the only other part of logic per se that is there is this will get the environment. Where am I executing this? As part of a pipeline parameter. Okay, and that parameter that you can anyway, that's coming from your, when you're creating those deployment jobs, you're going to say dev, pb prod, pr prod, and all of that, right? So what that means is this value should correspond to a environment file here also, right? So for each of these things that you've written in the deployment job, there's a corresponding environment manifest here. Okay, and as you do that, PPQA, there also exists a PPQA. There also exists a PPQA secrets. There also should exist a PPQA, kube config. Okay. Now that is anyways there in the secrets file. Now if you go to CI secrets, you will be able to find, let's say PVQA also here. Okay. So that is a secret here. So whenever this the what the value that's coming here environment, we are going to say for this particular build that you are doing, mount the pb-qa-kube config, which is there in the environment, the CI in the CD. So what will happen is there will be a kube config that will be mounted in slash root slash dot cube slash config, and the config file will be in the dev kube config. If you're running the dev build, if you're running pbqa build, it will mount the kube config file, and then you will actually run the script itself. Okay, so that's how it will get the whenever you run a particular deployment job, where it needs to be deployed from will come from here. Okay. Now the after that, whatever is that, this is how you run locally. Whatever parameters you pass, hyphen c, hyphen e, no, in the list of images, it's the same thing. It's just going to call those images. Whatever you provide in that box will come here as the images here. Okay. If I provide x, y, z, that same thing will come here in this variable, and we'll pass that. That's all. Okay, this is very actually this deploy.ruby is not really doing much because the actual code is outside of it. Okay, so we'll go see that next.
Nitin, that GCP key that you have, right?
Huh.
On top of it, like.
Yeah.
So in case of state using this, right? State or anybody,
Huh.
so it can be replaced with their own credentials, right? Necessarily it should be Google credentials only.
No. So I'll get that. I'll come to that why we are using this, or I'll just finish this now itself, right? So here, what we are doing is, so this deployment itself, right, has nothing to. It does not care about the GCP or whatever. You don't need not use any of that also. So why we use this is because of SOPs. When you want to decrypt the secrets with, when you're deploying with cluster config, you need to decrypt those credentials, right? Now when you're decrypting those credentials, you that whatever is there in the .sops.yaml, it will try to decrypt it with any of the methods. Okay, one of the methods will be with GCP. If you define the GCP key, if you define the AWS thing, it will try to using that, right? So in case now in the sops.yaml, right, you've actually, in fact, we had that change recently also, right? Here we are saying that all the before we had GCP for each of the entry. The reason being, our CD was always had this key, direct GCP key. So what it used to do is, it used to always decrypt no matter which secret. It used to use the GCP key that we're injecting here to decrypt those secrets. Okay. Now, if these secrets are all encrypted with an AWS key, like we are doing it right now. Okay, you can see everywhere it's KMS, right? So what happens is, again SOPs will try to decrypt it. Now SOPs will have a procedure, like it'll try to decrypt, okay, is there any AWS underscore access key, AWS underscore secret key, AWS underscore region, those environmental variables instead of GCP. If those three are configured, it will try to use that to connect to the and to AWS and decrypt it. Okay, so you can change this GCP key to AWS key, it will try to use that. But here we are not using this AWS environment variables, nor are we using GCP because we've removed the GCP account from here now. So how is the decryption happening without environmental variables? Because it's happening via instance auth. Okay, So AWS has this method, in fact, all the clouds do, where you're saying that the instance that is running can is you give it a role which says I am role, which says that this instance can automatically decrypt using this key. You will grant that access. If you give that, you don't even need this environment variable. Okay, so you can use any sort of this. This basically it is not tied to GCP or anything. You can use any sort of keys, any sort of PGP keys, whatever you need. Okay, this is the way you prepare the manifest. Where is this build deployment job? Where will it run? Which pod? That pod's definition is this. So if you can do it however you want. Whether if you want an instance auth, then you don't have to specify any environment variables. If you want to do GCP auth, then you will specify this environment variable. If you need let's say a PGP key, then you will mount a secret into a file so that the PGP key decryption happens. Okay. Now maybe if you have some kind of vault integration, so maybe you will provide vault URL and stuff. Okay. So yeah, I mean to answer your question very briefly, changing it to GCP to AWS or Azure or whatever will automatically use that for decryption and it will work. Okay, any questions here?
That instance auth in how to means which IAM you are using exactly? Means like in CICD, and I checked. I created one IMA for partners for Shravan to encrypt and decrypt thing.
Okay.
It worked. Means I just created one role for the decryption KMS and encryption KMS and provided the ARN, that whatever we are using the ARN, no? That
Oh,
one in
okay.
resource,
Okay.
and they are able to encrypt with that. Means that's it we have to do. Yeah, means like it's auth instance means like AWS. See our CICD, na, it's means how we are passing that auth instance. I'm not getting that.
Okay. So anyways, that you can just read about AWS instance of that's a bit out of scope. So if you see, okay, I can there are plenty of articles about this. So what this does is you have the IAM role. Now the role that you create will be the same. You would have created some IAM, some role there in your thing also. Like whenever you gave him access, right? You
Mm-hmm.
tied that role to his AWS access key or the user, right?
Mm-hmm.
Now, instead of tying that role to a user, you will tie this to the machine.
Mm-hmm.
Okay. So what happens is normally what you do is you will, whenever you present that user ID and password, it will recognize that, oh, okay, this is the person.
Mm-hmm.
Okay. But in this case of machine auth, what happens is AWS, you can tie that role to that particular machines. Like whatever all the machines that start from that CICD group of auto scaling group, it will start automatically with a token which says this machine, whenever it connects to AWS servers to decrypt this particular key, it should be allowed.
Okay.
Okay. So whenever it goes there, it will be able to decrypt.
That KMS you created in ePass
Right.
has authority to encrypt and decrypt everything,
Right.
whatever running in under the CICD.
Right.
You mentioned somewhere at the time of creating KMS, it's just normal creation of KMS.
Mention what exactly?
Means allow this key to encrypt and decrypt inside the CICD.
No, no. So the KMS only has one thing. What a KMS does is it is very simple. Uh, Given if you hit this particular endpoint and if you have the access rights, it will
Mhm.
allow you to encrypt or decrypt. Okay, that is a normal KMS. There is no additional setup you do. That is how you create KMS, and that is the working of KMS. Now, who will you grant access to use this KMS? That
Mhm.
is a separate portion. Now you created that to grant access to Shravan, a user, console user, correct?
Yeah.
Now that is you granting that access. Now that access control, if it says allow him, it will allow him to do the KMS normally. To KMS service, it doesn't matter. For KMS, it doesn't matter who is doing the encryption decryption. All it knows is there is another authentication authorization framework behind that. If it allows him or her or a machine to use that service, it will automatically encrypt and decrypt. Okay, so there during creation of KMS, there's nothing. During creation of CICD machines, that is when you will specify that to these machines I will assign another role which will automatically allow it to access the KMS without username password. It is done during the CI/CD creation, machine creation. Okay, again, this can happen for any service of AWS. You can now, if you want to do auto scaling of Jenkins, now how is that happening? Even that will not happen without. You cannot do auto scaling of Jenkins instances without it having an IAM role permission which says this particular machine can increase the number of instances that are running or decrease the number of instances. That is again an IAM permission that you grant to the machines. Same thing, you might need sometimes you might need a way wherein saying this machine should be able to access my S3 bucket without using credentials, because whenever these machines come and says that I am this machine, this is my IP, you trust it and give it. Again, that is also a machine auth. So AWS provides this machine auth for any of its services. It's not related to KMS. It's related to AWS with any of its services.
Okay,
Okay.
means while creating a CI/CD structure, you are creating IMA manually. It's just it create automatically that
You
thing.
have to manually create it, either part of Terraform script or you create it manually, whichever you like.
There we have to mention this KMS allowed,
Correct. You have to.
auto scaling, all the permissions we have to
Yeah.
allow
The,
the time.
the roles will already the roles there will be roles that you create which says a particular role. With that role, you can decrypt using this KMS key. You can do encryption, decryption, and then maybe you will create another role which says this one can do auto scaling of this auto scaling group. Now, when you bind these two onto that instance, it will become an instance role, and that instance will now have permission to do those things.
Okay,
Okay, you can read about it. I mean, it's not ego specific; it's general AWS thing. You can read about IAM machine auth or instance auth. A lot of articles are there. It's a good concept. Nice read actually.
okay, sure.
Okay, so the actual deployer itself, right? So now the actual deployer is there in the ego deployer folder. This is how it is being built. Okay, it's a Golang app. So it also once the app is done, it has a bunch of dependencies like kubectl, Helm, AWS IAM authentication thing. So those dependencies, those are all part of this Docker file. Okay, it gets created, and this ego deployer image is what is being used here. Okay, it already consists of the Helm and whatever is needed for kubectl and stuff will be part of the Docker image and it will run it. Now the code part of it, what code is written to run this? Again, the code is fairly simple. It's in fact just one file. Okay, one file with about 200 lines of code. Huh? Yeah, 250 lines of code. That's it. Um, Although I think the function part of it is fairly straightforward, right? Let's go to the main. Okay. Okay. So whenever okay, so whenever you run this command, what all things happen, right? You this whatever the output came. So what all are we doing to get this output? That is part of this deploy.go file. Okay, we are passing a few parameters. which is hyphen e dev, which is the environmental file. Okay, this is print only, don't execute, and the list of images. Okay, so this is what we are doing. Now, how does it actually work? What all is happening, right? You can think of it as in, uh, I think we recently had a scenario where a guy from the NIC, right, actually went to each folder and of the Helm chart and then deployed its charts. Correct. But he did it manually because he didn't know how else to do it. So he went to each folder of Helm for 150, 60 services. One after the other, he did Helm dependency update and then Helm template hyphen F, the file name, and then we did a kubectl apply of that. Now here also that same thing is happening. There's nothing else different that's happening, except we are doing a little bit of additional things so that to ease those efforts. Okay. So when you're doing first thing, right? When you're doing this, so normally this is how we are deploying. We're going to say go run main deploy. When the even in Jenkins box that deploy build images box, you put a comma separate images like this, right? But for actually deploying it, what we need to know is where is the chart for these images that you're telling. You are giving it Docker images, but it needs to find which directory to execute this, right? Matlab, which service is this for? You got it? So we need to know that part of it.
Yeah.
So that is what we do there is we take before the colon. We split before the colon. We actually just split it at the colon. When we split on the colon, you get two parts. The first part is the service name. The second part is the tag itself. Okay. Now
Mhm.
what we do is we take this service part. From this service part, we get all the directory structure and we search which directory has eGov-user. Okay. If we have more than one eGov user in the directory given, let's say in the Helm directory, because it has many subdirectories, somebody has created two eGov users. When we find that there are two eGov users, we will throw an error saying there are more than one eGov user. Please try and fix this because it could be ambiguous. If there is only one eGov user directory, we know the directory now. So we found the directory name is found. And the next part is just to run the command itself. Okay. Now what command is actually run that you can also see here. Okay. The final thing that you need to run is this. Okay. Now the image tag and the DB migration image tag. When we split on colon, you get two parts. One is the service name. Correct. Now the second part is the tag itself. Now the same tag you pass set the values of that tag. Okay. And the dev.yaml is also found because we are saying hyphen e dev or hyphen e pbqa or whatever it is. When we find that, what we do is we go into helm wherever the directory you are in, then to environment folder and we try to find a dev.yaml or qa.yaml or pb.yaml. When that file exists, we will pass it here. So basically what we are doing is we are reconstructing this Helm template statement. That's all.
Okay.
Okay. Now manually, if you are going to do, you have to cd into the chart directory like this. Where this what we are printing here in the first line is where do we want to execute this statement? That is the directory. Okay. Normally, if you are going to do first, you have to do cd into this directory. Then you have to type this command. And once the output of this, you will pipe it into a file, and then you will do kubectl apply hyphen f of that stem.file. That is all you do, right? That entire part is just automated here. That's all. What this one will do is for each comma separated thing that you put, it will take the first chart, it will go to the directory, it will run this command, the output will come, it will apply it to the cluster. Then comma next service, ego MDMS service. It will do the same thing over and over and over again.
Nitin, sometime na means a developer na they use like DB image
Correct.
divide. How it is means how it is find means it, DB is a different. We don't have a chart with DB, right? Something.
We have a chart with DB.
Okay. Ego user
Don't
DB.
have a chart with it. Okay. There is an image with DB. Okay, but we don't have a chart with DB. Now
Yeah.
again, that part is, see again, what we ideally expect is for them to put the exact name. Okay,
Mhm.
but in ego part practice, what has happened from before is even if they put hyphen DB, it should work, right? That is what they have got a habit. Now, if you tell that no, no, you put it without hyphen DB, they'll be like, oh, no, no, before it was working, now it's not working.
Yeah,
Okay,
yeah. That's
because of that, what we have done is we've done a replace. Okay, we have first what we do is we get the image name and then we replace hyphen DB colon with colon.
hmm
Okay, the understanding behind that is in the Docker image, right? The colon can only appear once. Okay, and
hmm
in all our DB images, the as of now the idea is it will only be ego hyphen user hyphen DB colon always. Okay, so what we are doing is even if somebody deploys hyphen DB a colon, just replace that with colon so that that hyphen DB is gone, and then you can do the deployment. Okay. Now this is a part of custom code that we've written because developers are used to doing that, so we've done. Now instead of you sending a notification saying, guys, please do this, it's easier to write this one line of code. That's why it's written.
Okay. Because I've seen a lot of time they are using the hyphen DB thing.
Yeah, because now if you were that would have cost a huge chaos if you just told guys, please change, please change.
Yeah.
Instead, one line of code will then take care of that. Okay. So apart from this, there is one other feature that's being added. That is in this function, a small thing. It's a get image from cluster. Now, anywhere you have the kube config inside of this deployer, image that you are going to run, right? Because you are going to do a kubectl apply. So whichever environment you have to deploy, that kube config is already there. Okay. Now what we are saying, if this guy does not deploy paste the image, means colon one hyphen that is not there, then you try to get the image from the cluster current image that's running. That you can do by running that command, whatever kubectl get deployment, whatever. Here that command is also there. Okay, in that with the JSON path deployment hyphen l app service name, then JSON path we give to actually get the exact image. Okay, we get that image and then we use that tag instead. Okay, you can see here fetched image from cluster. This is the cluster that is, because you have not put given the colon, right? What we are going to do is, okay, in the cluster the image that is currently running is this, so use the tag as whatever is done. So what it will do is basically it will do a redeployment instead of or a restart of the app instead of you having to know the image name all the time. Okay, that is the other extra feature that's being added. Now, apart from this, I think that's almost it.
The tag thing, it always connect to cluster for that tag.
Yeah,
Means always connect to that particular service. After that, it will grab to that particular tag.
won't connect to the service. It will just kubectl, because whenever you are doing deploy to dev, right, it will start a pod with the dev kube config in it already.
Mhm.
Oh, so if somebody is not putting the tag, which means he wants a redeployment to happen. So what we do is we do a kubectl, that service name we already have, which is eGov user. Now that eGov user, what is the current running image? We will get that, and we will redeploy the same image. That's all.
Okay. I thought like this work like whatever we are mentioning under the environment file now, it will deploy that thing always. Means like dev YAML we are mentioning some default image for the backbone, right?
Right, right.
I thought it worked like that. It's always connecting to the cluster and taking the current running image ID image tag.
No, no, no. Again, see, it's not. The thing is, it's not always like that. So there are three levels even in this case. Okay. Uh, Let me tell you. Okay, so now there will always be cases where the cluster, whatever you've deployed, right? The image you've deployed or something on the cluster.
Mm.
Okay, there might be eager user one hyphen something something. You've already deployed it. Okay, now if that image is there in the cluster, first time you already deployed it. Okay, but you have not provided, then of course it can go and get it from the cluster.
Mm-hmm.
But there are cases, imagine backbone cases. Okay, only in backbone is the place where we've hard coded the image tag also inside of the YAML itself, right?
Yeah.
Like the Kafka image name and all of that, correct?
Yeah.
But the first time you deploy, you don't give the image name, do you? You just put Kafka v2.
Yes.
Okay. Now it can try and get it from the cluster, but cluster it is not existing only. Okay. In that case, what it will do is it will pick whatever is there in the YAML itself. Okay. So it is not that it will not pick what is there in the YAML. But what it does is when you don't give a tag, it will always pick from the cluster. But there will be cases where it does not exist in the cluster also. Okay. In that case, what we do is we will pick it from the file.
Okay.
Okay. So this is the deployer part of it. Okay, there's one last part of deployer, right? That's also there. Now, there are some places like ego user and stuff. Okay, so in this chart, we have, okay, so in this chart, ego user, you can see there are two YAMLs here. Okay, so this is another feature that we've added. Okay, why? Because there are some scenarios where we want to use the same ego user image. So right now, how are we finding out? How are we finding out right now? When you say ego hyphen user, right,
Mm-hmm.
or and the colon tag name, which folder should I go and deploy the chart from? That is found out from here. That is clear, right? We will get that and we will search which directory exists and we'll deploy it. Okay, from the image name. But right, but there is a issue here wherein imagine if somebody wants to same deploy the same Docker image with a different set of variables under a different deployment. Okay. In the sense, maybe in eager user, there are same Docker image they'll use. But if the environment variable which says v1 is deployed, it will run the eager user same Docker image but with v1 flag, environment flag. But if you set the v2 environment flag, it should run the v2 image. Okay. Now this is not a problem if you can run them separately. As in one environment, you only have to run one such image. Now, what if you want to run two such deployments parallelly in the environment? Okay. So that time, what because of our deployment structure, what we will have to do is we will have to create another Docker image. Okay, just to deploy that v2 flag. Even though it is the same, the image name should be different. That was the criteria before.
Mm-hmm.
But now what we do when we are parsing all these files, right, at the initially whenever you do the deployment part, what we do is we get the entire charge directory structure. Okay, and we make a map which says if the service name is this, then you go to this directory. Okay, because whenever you do eager user, it will find where is the eager user directory and it will keep a map. Okay, the map will be such as eager user comma directory itself. And this is the map normally. Okay, and so on and so forth. Like if you're doing a searcher, the map will be this. So whenever you get the actual app, when that comes, that in that whatever you're deploying, if you say the service name is eGov user, it'll go deploy that in that folder. Okay, if you're deploying eGov searcher, it'll go deploy in that folder. That is the regular scenario. But in this scenarios where there are two of those values.yaml, okay, while making this map, we will check in these directories, are there any files with star hyphen values.yaml pattern? Okay, and if there this exists, such as this pattern files are existing. Okay,
Mhm.
then what it does is it will take the pre-value. Now what it will do is eGov user hyphen enc. If somebody deploys it as this, folder name is this. Now there is another one called eGov hyphen user hyphen value. So what happens? EGov hyphen user, if it is there, you deploy this. Then it again continues on. Okay. So in this scenario, what happens here? If somebody deploys, wants to restart or redeploy or whatever, if he types eGov hyphen user hyphen this tags here, okay. When you do that, it will go and deploy this service, which means it will deploy the values that are there in this manifest. Okay. But if somebody deploys eGov hyphen user alone, then it will deploy the values in this manifest. Okay. Now, does this image actually exist? No, it does not exist. Okay. What the first part of this in whenever you're deploying, the developers think this first part, or ideally everybody should know this, that the first part of what you deploy is not exactly the Docker image always. It is it this will only show where is the manifest location. What is my service name that I'm trying to deploy? 99% of the times, the service name is equal to the Docker image name. But in a scenario whereas this, where the service name is different from the Docker image name, it will go to this values.yaml. The repository will always come from here. Okay. The repository, no matter how, wherever you deploy, however you deploy in any kind of image, the repository always come from the manifest itself. So even though you are saying that this is my image, I mean this is my deployment thing, the image name that will be deployed will be this, because the repository under the egov user enc values still says its the repository name is hyphen egov hyphen user. But the env values and stuff again might be different in this particular manifest. Okay. So that is the difference between this. This is a rare scenario where you might want to deploy an image, a same Docker image, okay, a same Docker image, but with slightly different environmental variables or any such thing parallelly in a certain environment. Then you will use something like this.
Okay.
Okay, so that is all. Like, I mean, this covers all the deployer features. So one is it needs to find out which directory. Basically, when you say this, where do I have to execute? Okay, that is the directory it has to find out. Once it finds that out, it will prepare this helm template wala command, and it will run the helm template command. Okay, and then below kubectl apply of the helm template commands output. If you've done a comma separated values of multiple of them, this the same process will run in a loop. That is the entire deployer.groovy job. Not go job. Okay. So next we'll go to shops. Any questions before that?
No.
I think shops, I guess most of you know. and we partially covered also, I think, already. I don't know. Okay, not okay. So the entire SOPs, right? So we use SOPs for encryption, decryption of secrets. Now there is no before we had a mandate, we have to baked it into the deploy.groovy, which says that sops.yaml is mandated. But now there is no such thing. Okay. In fact, in the deploy, if you see it, if the file called .sop.yaml does not exist, okay, we will not run the sops decryption command at all. Okay. So if somebody wants to not, he does not want to run a SOPs or anything in your system, right? So what he can do is wherever the Bihar dev, whatever secrets are there, right? He can keep the secrets plain text. Okay. And he can manage the encryption, decryption manually, not manually, however he wants, he can do it. But before running our program, if he decrypts the file, keeps the file there, or and then runs the program, it should work as expected without needing SOPs at all.
Mm-hmm.
But if somebody wants to use SOPs for encryption, right, that is where we will come into this topic itself. Now, what we do in SOPs, the entire thing is very detailed, described here. Almost everything as to each uh, how to use with AWS, how to use with GCP, how to use with Azure, how to use HashiCorp, how do you rotate. Everything is written here. We just use the same part of it. The main part of SOPs is the SOPs.yaml, where you say that for this file pattern, right, encrypt it and decrypt it using this keys. Okay, so you will encrypt it using all of these keys. While decrypting, you just need one of these keys. Yeah, so that's pretty much it. Like, there's nothing much here. Uh,
Just for PGP, no. For Bihar, how it is working for the Bihar state means they are like PGP always like you provided me the key, right? It always be on your local machine to encrypt that things, right?
Correct.
But how it is working for Bihar? Previously means before this one, UKD was using PGP only, right?
So the thing is PGP, right? Why normally PGPs are added is, imagine you come into a scenario where your cloud account is compromised or you don't have access anymore. Somebody has deleted that encryption key. Okay, something happened. Okay, if you just rely on cloud and something happened, what is the actual use of PGP is these PGP key, you will keep it in a pen drive, and okay, in the traditional banking scenario, these PGP keys are stored in such as a flash drive or something similar, and they are stored away in a bank safe. So that if everything else fails, you still have a physical way of recovering this data. Okay, because imagine you have this encryption key. Okay, now you are only having KMS. Okay, here in this case, EPAS microprod. Imagine this KMS account got closed, or they banned your account, or something happened. Okay, which means you don't have access to the secrets also. Now that secret can contain anything, maybe some SMS accounts, username, passwords, or some other things. Okay, bank accounts, or whatever it might be. You will never get them back because there is no way to decrypt them without this. Okay, and if the key does not exist, you've lost your data forever, basically. So that's why you usually always keep PGP. Okay, because even if the cloud account fails or something happens, whatever, some data, some problem with the cloud itself, you always have PGP so that you can recover your data from your local machine. Okay,
Okay.
that's the reason for PGP normally. Now, in case of Bihar or UKD, usually what we do is the CD is anyway always outside our CD setup. We've never put it inside. So it doesn't matter whether we use PGP, but it's only used for encryption because decryption anyway happens in the CD using GCP key or the KMS key, and we deploy it. Now the PGP key will actually come into effect in this case. Ideally, it should come into a case only in this break the break glass situation where you really need it. But In case your scenario, you are deploying it in a state data center and they don't give you access to internet. Okay, then you have to use PGP for all your deployment. So what will happen then is your PGP public key you will export and keep it in your local machine. You will encrypt using that. Once it's encrypted, decryption of it will have to happen in Jenkins level. So like I had earlier showed, right? Here there's a what we mounted itself. Here instead of mounting something like this, you will mount the GCP, the PGP key itself. Okay. Once you mount the PGP key, SOPs will automatically detect, okay, the PGP key private key is existing. It will decrypt using that. Okay.
Okay.
But ideally, PGP key, what our use case and the recommended use case is as a very, as a fail, at the last moment, as a break glass approach, you use PGP keys. Otherwise, you always use the cloud one. Okay.
Mhm.
Or if you have a Bihar or some state data center where CICD also has to be inside the state data center and they still want to use SOCs, then you will use.
Okay.
Okay. Apart from that, I don't think much is there about SOCs. I mean, based on this, it's going to encrypt by connecting to any of these things. I mean, decrypt by any of these things. It will try this method. Um, of course, it has plenty of documentation here. But, okay, one more thing. I mean, again, these are all mentioned here. This is not if you try to just copy the secret because we've seen it many times. What these people do is they will copy the username from dev because dev password username encryption is the same. What they will do is they'll copy and paste this in QA also and expect that it will work. It will not work because we will also in each of these we also have a Mac, which is like a checksum. Now this checksum will not match if you go and manually edit the file. So if somebody is asking you, always say ask them that you need to always edit these files using SOX, okay, which will generate the the accurate MAC and then give it the
Okay. But Nitin, we for every environment, and now currently we are using the one KMS value itself, right?
yeah.
Shall we change it to every environment? Why we have to keep it like that only?
Yeah, so here what it is normally what everybody does, okay, is the idea is the the CD setup, right? You should
Mm-hmm.
have a key of the a single key for the deployment itself. That's how it was all these days, right? The GCP key that is there, nobody has had access to that GCP key except for that instance which is running the deployer job. Okay.
Mm-hmm.
After that, there were KMS keys for each environment.
Mm-hmm.
Yeah. Even now you can do the same. As of now, what we did it as a quick fix. We had to do it, so we did that. Ideally, what it should be is this KMS key that you've used, right? This what the CD is using or CICD. That KMS key should exist, but you should add an array, make it an array, and add another key which is the state-specific encryption key. So what will happen then is you are encrypting and decrypting with multiple keys.
Mm-hmm.
Okay. The decryption key you can of one will be the state specific one. That key you can give access to the let's say the LZAM or whatever that implementation teams. Okay. So what they will do is if they want to decrypt, they have the key. They can decrypt it and they can encrypt it and save it and PR and everything can happen. We won't need to access their key, but they will be encrypting with our CI/CD key also, so that our CD will be able to decrypt. Okay. Ideally, that is the process you should get to so that you also don't have access to the secret.
Yeah, but here now we can only define like I also search it when we can only define only KMS one
No,
KMS value.
in the KMS, when you put KMS here, there is There's another something which will give you an array and all. So just check that. So you can do something like KMS and then array, and here you can do name, key, something like that. AWS and profile. This structure is there. Okay, then you can put another one, saying another one. Okay, so this is there. So just use something like you'll have to use something like this.
Somewhere now they use comma also in KMS value, no?
Uh,
Comma separated keys, ARN keys also worked somewhere. I checked some.
yeah, I mean that's what I mean. Both of them should might work because now when you do this, this is basically an array.
Mhm.
Okay. Now if the array is you don't have any AWS profile, means what is this? This is just name, 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 which you can also simplify as this, the values itself. Okay. So you Google and see whichever suits what your needs. Based on that, you can create. Again, these are all SOPs things, so you can Google about SOPs, and there will be some ways to do it. So you can do that. Like so, give state specific key. Also have one CD key. So the deployment, whenever you're doing deployment, it should be able to decrypt and deploy this manifest. At the same time, the states can control their own secrets. They will also have their own value. We being the middleman, ideally we should not have any of the access to any of the secrets.
Yeah, sure.
Hey, Nitin? Gaja.